All right, so first of all, I want to invite Dr. Gunjan Mansingh, the head of department the head of the Department of Computing, to just bring a word, greetings from the Department of Computing.
Thank you, Claudine, or I should say Dr. Allen. Well, welcome to Dr. Wiegers. Am I getting it right? It's a pleasure to have you. I've read about you in your abstract, which is just so exciting, the thoughtless design of everyday things. And then I look at your background and where you come from chemistry, and how does a chemist go into a design is even more intriguing for me. So I'm really looking forward to your talk. And design, as we are all seeing, that design has become so important, around us. Empathy with the user, as we are all software developers working in this world where everything is evolving at a pace which is beyond our imagination. So welcome to our weekly talks. We have this weekly seminar series, and I'm really happy that to have you for this session. So welcome. Over to you, Claudine.
All right, I don't want to, all right, so based on the time, let's go ahead. I'm going to hand over to Dr. Wiegers, but before I do that, I'm going to do his biography, right? That's always good. All right, so Karl Wiegers is principal consultant with Process Impact, a software development, consulting and training company in Portland, Oregon. He has a PhD in organic chemistry. Of course, that really just stands out as quite interesting, as Dr. Mansingh mentioned. Karl is the author of 13 books, including Software Development Pearls, The Thoughtless Design of Everyday Things, Software Requirements, More About Software Requirements, and there are many others. And some of us are familiar with some of his books, actually. Karl has also written many articles on software development, design, project management, chemistry, military history, consulting, self-help, as well as, get this, he's a songwriter and singer, and he actually has several recorded songs. He will probably give us his website. You can go there and you'll see his songs, and you can listen to them. Amazing. So he has delivered hundreds of training courses, webinars, and conference presentations worldwide, and you can reach him at processimpact.com. And over to you now, Karl. Thank you very much for being here, and a warm welcome from the Department of Computing and all our colleagues across the Caribbean.
Great. Well, thank you very much, Claudine. I appreciate the introduction and the invitation to join you all this afternoon. I'm glad you took some time out of your day. It's the end of the day for you. I'm on the West Coast, so it's a little bit earlier for me. I don't know about you, but I encounter a lot of products that seem to be designed by someone who apparently has never used a product of that kind before. And I suspect you've had similar experiences. I run into software applications, websites, and physical products like household items and cars all the time that just make me wonder what the designer was thinking. Now, sometimes we might have trouble trying to figure out how to use a product, and that can make us feel dumb. But usually it's not our fault. Much of the time, a product that's hard to use is not designed well. So I wrote this book, The Thoughtless Design of Everyday Things, to share some of these experiences and to see what we can learn from them about doing better product design, and also what we can learn about how to be better consumers by understanding our own requirements before we go to select a product. And you might have had this experience too. You go to the store to buy some ordinary thing. You have an idea in mind of what you want, and you find one that seems about right, and you take it home. You start to use it and you realize, well, this is stupid. This is not going to work for me. It's got some design flaw, but you've already bought it. Now you have to figure out, well, do I take it back or do I throw it away or whatever? So we've all had those kinds of experiences, I think. And I want to start by sharing with you an experience I had along these lines just a few days ago. I somehow acquired a little device here. Okay, this is a magnifier, an illuminated magnifier, which is helpful if you need some close-up assistance for reading, or if you're working on a a project, like an art project, and you want to get a close-up look. Okay, so this is from the National Federation of the Blind. It says, for help with blindness, please call a phone number. Okay, so I looked at this and I was trying to figure out, how do you turn the light on? I know there's a light in it, but how do you turn it on? So I flipped it over on the back, and here it says LED lighted 3X magnifier. That's the name of the product. Slide apart to turn on light. Okay, it wasn't obvious to me, but slide apart. Let me show you what happens when you slide these two pieces apart. Can you see that? It's got a very bright LED light, and I'm not looking right at it because when I first did this, I did look right at it and I was nearly blinded by this laser-like beam of light going right into my eyes, coming from the same side where the instructions were to how to turn on the light. Let me see if I can do this without burning out your screen. Do you see how bright that is? That was painful. Now, somebody who designed this and decided where to put the instructions about how to use it. First of all, it shouldn't need instructions, I don't think. Second, they might have put it in a way that wasn't going to immediately require you to call the blindness hotline here because your eyes were blasted out. So that was kind of a timely illustration of poor design. So I'm going to turn my camera off here for the rest of the presentation, just so as not to be a distraction, but I'll come back at the end and we can do some Q&A if people have any questions. If you do have questions, feel free to put those in the chat box and we'll get to those later on. So I am going to begin with a definition of what I mean by thoughtless design and describe 3 reasons why design is a hard problem. As I was writing this book, I looked at lots of different examples. In fact, I have over 220 or so examples of products in the book, most of them not good examples, but also some good examples of thoughtful design. But as I was writing these, I identified 9 fundamental principles of good design. So the book contains more than 160 examples of products that don't conform to these design principles, along with some suggestions for how to improve many of those designs. And today I'll show you quite a few of those examples of thoughtlessly designed products. But I also describe almost 50 examples of what I think are particularly well-designed products in the book. And I'll show you some of those today. And you've probably had this experience as well, where you use some product or some website or something and it strikes you, it's like, wow, this is really nicely designed. This is kind of a pleasure to use. It's simple, I understand it. But I don't think that should be a pleasant surprise when we encounter a well-designed product. I think it should be the norm. And so we want to try to do a better job of making that the norm. So along the way here, I'm going to introduce about 19 of the 70 design lessons that I extracted from studying these various products. And I'll wrap up by summarizing some good practices for usage-centered design, which is very relevant, for example, to business analysts as well. And I think this is the best approach to building usable products. So let's talk about what I mean by thoughtless design. I have a nice blue jacket, pretty much like this one, that is well designed overall, but it has one peculiarly thoughtless feature. There's an inside pocket that's 5 inches wide. And that's a nice size for holding a phone or a museum brochure or sunglasses, something like that. But for some reason, the jacket designer decided to sew a big seam down the middle of that pocket, thereby splitting it into 2 much smaller and less useful pockets. I just simply don't understand why someone would do that. What customer said, this 5-inch wide pocket, that's way too big. Why don't you make 2 small pockets instead? I don't think anyone told them that that was a good thing to do with the design. I just don't understand how those things happen. So when I talk about something that's thoughtlessly designed, I'm thinking of products that violate 1 or more of my 9 design principles. And the sad thing is that many of these products could have been designed better with little additional effort, sometimes just a little more careful thinking and consumer engagement. In this case, they could have actually done less manufacturing effort by not sewing that seam down the middle of the big pocket. And it's not just a little thread seam that I can undo and try to make it larger. Nope, that's pretty firmly subdividing those two sub pockets. Let me define some terms that I'll be using here. A product or feature is obvious if its presence and usage are readily apparent without anyone having to explain it to you. I don't think I should have had to have some instructions about how to use this little illuminated magnifier I just showed you. A product is intuitive if you can make a good guess at how to use it based on its similarity to other products or from other cultural and contextual clues. You don't need to consciously think about how to use it, or you don't need to refer to instructions or a manual. You just use it. A product or a feature is easy to use if the user can successfully perform an ordinary task with minimal effort and assistance. So let's think for a moment about why all products aren't thoughtfully designed. I don't mean to suggest that product design is easy. It's not. And there are three major reasons why design is hard. The first is something we're all familiar with, and that's because designs are based on requirements. I've done a lot of work on software requirements for the last, well, really, I've been interested in improving requirements for about 37 years now. And we know how many problems people encounter simply trying to develop an understanding of the requirements for any kind of product. In fact, here's a picture of a very early business analyst writing one of the very first requirement specifications. Okay, I lied. It's really Charles Dickens writing some book, but it could have been a BA. And here are some of the reasons why problems with requirements could lead designers in the wrong direction. First, they could be incomplete. They could be inaccurate or obsolete. Maybe they were accurate at the time we wrote them or got that information, but by the time we get around to building something, it doesn't apply anymore. Sometimes we're not talking to the right people. We're not talking to suitable user representatives of the various kinds of users for our product. Or maybe we're talking to the managers of users, not the real end users, and so forth. Now, sometimes you don't have a choice. You may not be able to interact with real user types, but if you get the wrong people involved, you're probably going to get some inaccurate information. Incidentally, when I say product, I might say product or solution or system, whatever it is you're building, that's what I'm referring to, whether it's software or something else. I've worked as a consultant for a long time and done a lot of work with companies to try to help them improve their requirements processes. And the single biggest complaint I've heard from business analysts is that our customers don't give us requirements, they give us solutions. And so if you're writing requirements that are really describing solutions, you're probably going to come up with a suboptimal design. It's a very good idea to back up a few steps and make sure we understand the problem and the user needs, and then come up with solutions. A very common problem is that we focus on features, not on usage. And what happens then is we build a set of features that maybe seem like they are the reasonable things to include, but they don't really let users get the job done. So we want to try to avoid that. I think it's better to focus on how people will use the product, what they're trying to accomplish with it, not on the list of features to include. We very naturally, during requirements discussions, focus on functionality, the things the product will do or the things that'll let the users do. But we might overlook an assortment of non-functional requirements. And that's an important part of customer satisfaction. We'll come back to that in just a couple of moments here. And even if we did a good job on all of these and we came up with a good understanding of requirements, we might not do a bang up job of recording them and communicating them in a way that's meaningful and usable for the people that have to take the next steps. So without a solid, well understood foundation of requirements, almost any design you come up with is going to be deficient. Now, it's important to remember that perfect design solutions are unattainable, and any solution is always a compromise. And this gets to the second reason why design is hard, is that we have to try to please a lot of stakeholders who can have conflicting interests and objectives. So one source of tension in the design process is trying to satisfy the complete set of requirements and constraints that these various stakeholders present. And I've shown here just a handful of the types of stakeholders that you might have for whatever it is that you're making. And there's this tension between them. There are these potential conflicts. For example, certain product characteristics might make it easier to install or to service some product, but maybe those same characteristics aren't convenient for users. And I had a great example of that in the book. I was once visiting a friend and I was taking a shower, and I could not for the life of me figure out how to get the water in their bathtub to come out the top so I could take a shower instead of out the bottom. It was not at all obvious from the way the faucet was designed. How do you get the water to come out? Wasn't like anything I'd ever seen before. I had to request assistance from my friend. And I wrote about this, and at least 3 other people have told me they had exactly the same problem with exactly the same item in totally different situations. So I was kind of glad to know it wasn't just me. So another example is the manufacturer might like a design that's easy and cheap to produce, but customers aren't going to be happy if that makes the product less durable. Also, we tend to talk about the user, but as you can see at the bottom here, we have multiple user classes for almost every product. We don't have a user. We have different characteristics, needs, and expectations that all have to be balanced somehow. So it's very hard to make all of your stakeholders ecstatic with any single design. A third reason why design is hard is because a product exhibits many different quality characteristics. These are sometimes called design for attributes. In software, we often call them quality attributes. And when people describe non-functional requirements, this is what they're usually talking about. Here is a list of some of the familiar design for attributes for software systems on the left. And you've seen these kinds of things before, the so-called ILIDs, called quality factors or quality attributes for software. And on the right, I've got a supplemental list for physical devices, some of those design for attributes. And some of those products might contain embedded software. If you're building something like that, you have to worry about attributes in both of these categories. Bad news, I'm afraid. It's impossible to build a product that maximizes all of the desirable attributes. Even worse, some of these attributes conflict with each other. Increasing one can decrease another. For example, if you use, let's say, multi-factor authentication to increase the security of a software system, like maybe you're trying to log into your bank's website on your computer and it says, okay, I'm going to send you a text to your phone with a code, and you have to type in that code and then you can log in. Well, you've increased security, but you've reduced usability. So there are trade-offs here. Therefore, designers need to know which of these quality attributes are most important to business success, so they can make the right design choices and try to achieve the best balance. And that's why an exploration of these quality attributes is an important part of requirements development. You neglect non-functional requirements at your peril. As I mentioned, this book presents 70 design lessons that I derived from observing both poorly and well-designed products. And the products that I talk about, the lessons that I pull from them, that's not just my personal experience. I had many reviewers of the manuscript for this book, and I cast a wide net and had a lot of people submit to me examples from their own experience of design problems, and particularly good design. So there's a really wide range of examples here that we can learn from. So here are the first 3 lessons, and I think these are the most important. So my latest book, incidentally, is called Software Development Pearls. There are 60 lessons in there that I've learned from more than 50 years of software experience. And somebody asked me once, what's the most important lesson I've learned? And it's this one. This appears in both of these books. Focus design on usage, not on product features. I mentioned this earlier, and I'll probably mention it again as we go on. Usage-centric design means understanding how people will use the product. Think about not just the features, but what people want to do with it and the environment in which they'll be using it. Then design the product to make it easy for users to get the job done. And there's a side benefit here as well. You might have worked on a project, or might in the future, where you end up implementing certain functionality that people say they need, only to discover that no one ever uses it. That's very annoying, because you put just as much work into building the features that no one uses and as the ones that they do use. So if you focus on usage, that helps you avoid that problem of building in unnecessary functionality, because we're building the functionality we know people need to get the job done. The second lesson is that design demands iteration. You're not going to get the design right or perfect on the first try. You have to plan to iterate, approaching a better design with each cycle until you have a design that's good enough to satisfy the requirements. Well, if you're iterating on your design, How do you know what to change in the next cycle? And ideally, you'll have actual typical user representatives helping you with the design process. Perhaps they're working with a prototype or a mock-up under realistic usage conditions. So users will give you insights that you just can't get in the design lab. Sometimes you do have to work with user surrogates, but I've found that there's no substitute for having real users participate in the design process. So now let's look at my 9 design principles and see some product examples and some more design lessons along the way. The first design principle should hardly require stating. Make the product easy and obvious to use. Let me give you an example of a place where somebody dropped the ball on this. A couple of years ago, I rented a small SUV at an airport, back when people could still fly. Now, I don't have a lot of experience with SUVs. I've driven a whole lot of rental cars as a pretty extensive business traveler. But I could not, for the life of me, figure out how to open the tailgate on this car to put my suitcase in the back. I spent 10 minutes groping around in this dimly lit garage at the airport, looking for a latch, a handle, a button, a keyhole, anything. I couldn't find it. There was no button on the key fob, as there usually is with my sedans that I drive. I've got a button, I can just open the trunk. I couldn't find a button or a lever anywhere inside the car to open the tailgate. I finally had to ask the car rental people for some assistance. Now, the red circle that you see on the right, that red oval, shows the door opening handle above the right taillight. And that looks very much like the non-functional chrome piece above the left taillight. Is that obvious to you? It wasn't to me, and it wasn't at all obvious to a friend of mine. I was telling about this, and it turned out he had rented the exact same model of vehicle and had the exact same problem that I did. He had to walk 100 yards back in the rain from the car to the car rental booth and say, okay, how do I get this open? At least I didn't have to do it in the rain. I was in a garage. But there's an important lesson here, and the lesson is that small design problems can interact to yield unexpectedly significant results. We have this combination of a disguised handle, there's no opener inside the car, and there's no button on the key fob. And each of those was a small design choice, but putting them together made it impossible for me to open the tailgate, despite having rented dozens of different rental cars over the years. It wasn't obvious, it wasn't intuitive. Now, it would not have been much harder for them to provide these multiple alternative opening mechanisms that people are used to. And this is the kind of problem that should be discoverable during a prototype evaluation by real users who haven't seen this particular car before. What you do is you say, okay, I've got an idea for a kind of design here that's a little novel. We think it looks cool. It's real clean lines in the back. But let's see how users are going to respond to it before we start manufacturing these things. And so you would maybe mock up the back of a car like this, and you do some kind of a usability evaluation or a prototype evaluation where you ask people to perform certain routine activities like opening the hatch. And you check to see how long does it take them to do this? How many tries does it take? How many errors do they make? And what do they do next? So that kind of an assessment goes a long way to making sure that you've not made a design that people are going to have to struggle with. Because once you commit to this, a lot of people are going to have to do the same thing. This is another interesting point here too. This is not easy to learn how to open this, but it's easy to use once you know it. So there's this balance always between ease of learning and ease of use, two aspects of usability. Well, as it turned out, this wasn't the only problem with this vehicle. Once I finally figured out how to open it, it only opened about half the time. It was really hard to get that mechanism to work. And I eventually ended up leaving my suitcase in the back seat on my trip just because I didn't want to get to the airport and be unable to get it out of the back of the car. So I never rented that kind of car again. Here's another example of an unobvious design. I've got a lot of examples in the book of iPhones. I'm not familiar with Androids. I imagine they have some of their same issues, but I've used an iPhone for a while now, and there's some great design there, and there's some what were you thinking design too. And here's the latter type. This is the timer feature on my iPhone. Some of you have no doubt used this. The image on the left here shows how the timer looks when it's counting down, in this case from 5 seconds. The right image shows what the screen looks like after the timer countdown has reached 0. Now, the way I first learned about this particular feature, a very smart friend of mine with almost 50 years of software development experience used this timer one evening when several of us were playing a game. He set the timer for 30 seconds. Sure enough, after 30 seconds, the alarm sounded, but it took him, with help from the rest of us, 30 more seconds to figure out how to turn the alarm off. It's totally unobvious. Let's look at the screen on the right. There's a cancel button. Oh, maybe that turns the alarm off. No, it doesn't do anything. Now, the cancel button's present on the left, and you'll see it's a little darker gray on the right. It does something on the left screen, but when the alarm's sounding, cancel does nothing. All right, well, maybe I'll tap start. What does that do? Well, that restarts the timer while the alarm still sounds. And then the alarm goes off after that second timer reaches 0. And that makes no sense to me at all. So it turns out that this was not obvious at all to any of us. And one lesson we can get is that it's a bad idea to provide the user with options like the cancel button here that don't do anything or suggest that they'll do something different from what they actually do. Software systems should present the user only with unambiguous and useful options. It turns out that there are several ways to turn the alarm off. I think he finally did it by hitting the home button on the phone. Okay, that turned it off. There's that gray bar that appeared at the top, and you can tap that gray bar, that turns it off. Or it's got that little horizontal line, it means you can pull it down. So if you pull it down, then you finally see a prompt that says, do this or tap here to turn off the alarm. Wouldn't it be better to show that to the user somehow right away instead of making them hunt around for this? It's the technical term for this is stupid, in my opinion. Now, I encountered some surprising behavior in Microsoft Excel once. I had made some changes in a workbook that was still open, and that caused the undo function to become active. Well, that makes sense. When I then created a new workbook, I noticed that the undo shortcut button was still active, as you can see here in the red circle. But I hadn't done anything yet in that second workbook. There was nothing there to undo. So that kind of puzzled me. So naturally being, having a lot of experience with software and testers and stuff like that, I said, what happens when I click on that? So here's what happened. Excel reversed my most recent operation, not from this workbook, because I hadn't done anything, but from the first workbook. The view switched back to that first workbook after it did the undo, so I couldn't tell what had happened. I couldn't see anything happening. It was pretty confusing. This is not how undo works in PowerPoint and Word. We expect that members of a product family like those in Microsoft Office will show common behaviors from the same functions, and for the most part they do, but not always. So the first lesson here is to make sure that the user won't be surprised by unexpected and undesired behavior, like undoing something you did not intend to undo. But there's a second lesson as well. Use context to activate relevant functions. There's no point in having undo be active if there's nothing to be undone in the present context. So we find all sorts of design things everywhere we look. Okay, I'm going to move on here to my second design principle, which is to consider realistic usage scenarios. Last year, I bought a new wall oven. My previous oven had a literal meltdown experience, which was quite exciting. We weren't sure if it was going to go nuclear or what, but when it finally stopped melting, we said, okay, I think it's time for an oven. Here's the control panel for this new oven. I like the oven okay, but it has one absurd feature. One thing you want to do with an oven is use a timer. Back to the timers again. This oven does have a timer that sounds an alarm when it counts down to 0, and it sounds an alarm when it reaches the preset temperature as well. However, the problem is that this alarm is way too quiet. If you're more than a few feet away, you're unlikely to hear it over normal background noise. So here's a thoughtfulness scale that describes how this oven's alarm feature was designed. The nominal behavior is that the oven does indeed generate sound effects under appropriate conditions. The designers thoughtfully allow the user to set the volume to one of 3 levels. See, that's a great aspect of thoughtful design. which is to provide some customization capabilities. However, the highest volume setting is still so quiet as to fit into the thoughtless design category. And the lowest volume setting is just comical. So we have this 4-level scale here for thoughtful design. And this was definitely in the comical category. At the lowest setting, you have to stand right next to the oven to hear it, which rather defeats the whole purpose of having an alarm. So how could somebody build this? I mean, I thought maybe there was something wrong with my oven. So I called the manufacturer and they somewhat sheepishly said, nah, that's correct. That's what it does. But maybe this oven was not adequately tested in realistic home usage scenarios. My previous oven had a loud buzzer that I could hear anywhere. And you want that to be sort of a rude, pay attention to me kind of noise. This one sounds like the gentle tinkle of a distant ice cream truck, and you might not even hear it. It barely penetrates my consciousness sometimes, which is kind of frustrating when you're counting on the timer for something. So keep this scale in mind as you encounter, or even better, as you design products, and try to keep your designs away from the thoughtless and comical ends of the spectrum. Here's a lesson. We should design our products to perform well in a wide range of realistic usage contexts. You know, in a way, these lessons are stupid because the answer, the response to all these lessons is, well, yeah, of course, that's obvious. And yet we encounter products all the time that don't conform to these simple lessons. It seems obvious that products should be designed this way, but sadly, it's not always the case. Here's an example. Have you ever seen silverware at a restaurant or a cafeteria that has these smooth cylindrical handles like this? I have. You can even buy them. It's impossible to get a secure grip on these. The knife rolls in your hand if you try to cut a piece of meat or butter some bread. Be careful if you're eating cereal or soup with the spoon, because it can just spin in your fingers and spill food in your lap. I just cannot imagine why someone would design such an everyday product in a way that simply doesn't work well in an ordinary usage context. Our hands grip flattened and textured pieces of metal far more securely than these slippery cylinders. This is the kind of design that makes no sense to me at all. Well, here's another iPhone example that I think is quite thoughtful. The Contacts app. One of the things it does is it changes the input controls depending on which field you're entering content into. So for example, in the email field here on the left, the alphabetic keyboard pops up, which is the one you're probably going to want to use for email. Now, I don't know why they included the emoticons and spacebar in here, as I've never seen an email address that has those. But I'm guessing that they're reusing a standard keyboard control there. Now, this is an interesting point. Reuse is great. You know, we should reuse things whenever we can, but sometimes there's a little bit of a trade-off there. There's a little compromise between the value and efficiency of reusing some existing control or software component versus tailoring it to be exactly what you need for the reused scenario. So maybe it's a little trade-off. Doesn't hurt to have an emoticon and a spacebar, but it doesn't really do you any good either. Now, with the Contacts app, if you're entering content into a date field, like a birthday, then Apple's rotary date entry control appears here. I didn't show it here, but if you're entering a phone number, the numeric keyboard appears with the special characters you might need, and it attempts to format it in a way that's suitable for your environment. So I think this kind of thing is thoughtful design because using context to activate these appropriate controls saves the user time and it reduces errors. You can't put an invalid month in the date field if you can only choose from the 12 months of the year and the control they provide. I've seen input controls in other applications that do let users enter invalid dates like February 30th. That's not too good. You also end up then having to write code to check for invalid dates. And here you don't, because there's no way to enter one. Our third principle is to consider a wide range of usage environments. And here's another car example. I got lots of car examples. My sister, who's an IT person as well, was one of my manuscript reviewers. And I had 4 examples in here, I think, about car seats. And she said, well, isn't that really just one? It's like, no, they're all different kinds of problems. So I rented a car in January a few years ago. Remember that, January. Here's a photo of the climate control system. I've rented this particular model many times. It's a very common rental car, and I like them fine. But this climate control system, even though it has clearly labeled buttons and a reasonable, nicely symmetrical layout, I had a little problem. I found that I kept hitting extra buttons when I tried to adjust the controls with gloves on. January, remember? The buttons in some cases were too small and too close together to hit them precisely. For instance, if I pressed the rear defroster button on the right inside the oval here, I would also turn on the seat heater most of the time, which is the small button just to the left of the defroster. Now, when you're manipulating the controls of an unfamiliar car while you're driving, maybe at night, that's hard enough. But when you get some unexpected outcome like, why is my seat getting warm? I don't remember turning that on. It's annoying to have to try to figure out what's going on and correct it. So the lesson from this is let's ensure that the design is usable and safe in a wide variety of likely operating environments and conditions. This made me wonder if the designer of this climate control panel had somebody test the design while wearing gloves. And I kind of doubt it, or they would probably realize that those buttons, even though they look nice, are a little too close together to be easily touched without causing unexpected side effects. If you're building systems that contain software to be used in a variety of environments, here are some factors to consider. You might check to see how well it works under different lighting and weather conditions. I've seen ATMs at banks whose screens were nearly impossible to read at times because of screen glare from the sun. If a product involves audible input or output, like speech recognition or synthesized speech from a kiosk or something, make sure the sound levels are appropriate for the intended operating environment. They're loud enough for the user to hear, but not so loud as to disturb or distract others nearby. If you're standing at a bank of kiosks and it sounds like the one next to you is talking to you, that's kind of distracting. The fourth design principle is to make it hard to make a mistake. And here's another car example. These controls are from my brother's pickup truck. The knob on the left controls the headlights. The identical knob to the right, just a couple of inches, controls four-wheel drive. My brother's a mechanical engineer. He's driven lots of trucks, and he says that it's easy for him to grab the wrong knob when he's trying to do something, and that could lead to some startling results. You reach down to turn on your headlights and boom, you feel the truck shift into four-wheel drive or something. So symmetry like this is nice for visual design, but it's not always so good for usability, particularly by touch. Now, there are 4 ways a designer can consider how to deal with the possibility of user mistakes. The best option is to make it impossible for the user to make a mistake. That's not always feasible. So a good alternative is to make it difficult for the user to make a mistake. Maybe the designer could have made these knobs just different enough that a driver could easily tell by feel if they had the correct knob in hand. A third option is to make it as easy as possible for the user to recover from an error, either one of their own making or a system error or failure that takes place. And the worst option is to not give it a thought. We will just let the mistake happen and we'll force the user to deal with it. So the principle here is that we want to make products easy to use correctly, but hard to use incorrectly. Let's see a few more examples. One good design approach is to make it difficult for the user to take some destructive action by accident. This means making the options clear so the user isn't surprised when they take some action. And here's a nice example of how to handle that. This is the screen that I see if I ask to delete a mailbox, which is just an email address, at the control panel for my website. My website hosting provider makes it perfectly clear what will happen if I choose this option. Okay, if I want to delete that, then I have to check that or tick that checkbox, and only then does the grayed out button to perform the delete action at the bottom become visible and active. Even better, after I delete the mailbox, I see another message which says, well, if you did this by mistake, you can recreate the email address right on that same page, and the deleted mail will all be automatically restored to it. So they made it very easy to recover from this. So they're doing the right thing. First, they're making it hard to make a mistake. Second, they're making it easy to recover from a mistake. And even better, my web hosting provider gives me a month to correct a mailbox that I deleted by mistake. So I think this is an example of very considerate, thoughtful design that kind of gives you a comfort level that you're not going to find that you've done something you really didn't intend to do. Here are several suggestions about how to design products to help users avoid mistakes in those 4 categories. To make them impossible, one thing we can do with physical products is use asymmetry to make sure the pieces fit together properly. For example, there's only one way to connect a USB cable to a USB port. You can't get it wrong. Unfortunately, you have to see both ends to be able to connect them properly, and that is a disadvantage because the thing you're plugging a cable into is often not easy to get at. You're doing it by touch, and you have to take 2 tries. Always takes 2 tries. An even better solution is seen with the USB-C and Apple Lightning plugs, which are symmetrical, so you can't get it wrong. Okay, and that's a perfect solution. For software, don't offer the user options that are illogical. The ATM at my former bank always would ask me which account I wanted to use when I said I want to make a deposit or a withdrawal. It gave me 4 choices: primary or secondary, checking or savings. Guess how many accounts I had at the bank? That's right, 1. So it's just dumb to offer the user a palette of options of which 3/4 are meaningless. There's just no way that those can be correct. And then you have to write the code to recover if the user chooses one of those irrelevant or inappropriate entries. It's just not a good way to do things. Software can prevent mistakes by doing things like constraining or correcting or reformatting user input instead of reporting an error and then making the user fix it. Have you ever entered a phone number or a date and the web page decided it didn't like your delimiters between the parts of a phone number, or it didn't like the way you formatted the date or whatever? And instead of fixing it, or instead of constraining it in some way, they make you fix the errors. If an error happens anyway, the product should help the user correct it. Don't think of a problem report as being just an error message. Think of it as a guide to recovery. Now, if you're just going to let the mistake happen and leave it up to the user to deal with it, you do not need tips from me. You just, just let the user deal with it and see how it goes. I'm sure you've seen messages from computers that are just as useful as the one this guy is holding. And those messages always make you wonder, why are you telling me this? And what am I supposed to do with that information? So another important design principle is to provide meaningful feedback. There are 7 characteristics that meaningful error messages and other system feedback should exhibit. It should be immediate rather than coming in at some later time and you have to think back to, okay, what are we talking about here? Tell me something I don't know and need to know. Make them informative. The feedback should be necessary. One website I use sometimes shows me that I have a notification when I log on. But when I click on the icon to access my notifications, the only message I see says, you have no notifications. That's an example of unnecessary and time-wasting feedback. I'm big on not wasting people's time. The message needs to be clear. I need to understand the point. Otherwise, why bother showing it to me? It should be actionable. It should help me know what to do next. And persistent. Don't you hate messages that flash by long enough for you to see that there was a message, but not long enough to read it and process it? Someone else decided how fast you read and think. So messages that aren't persistent can be annoying. Finally, messages should be polite. I'll show you an example of a polite message in just a moment. So let's see some more feedback examples here. I wanted to cancel a magazine subscription, and here's the dialog box I saw when I submitted my request. This message is ambiguous. Okay, these are the traditional Windows dialog box responses, okay and cancel. Well, if I click on cancel, will it cancel my subscription like I'm trying to do? Or will it cancel out of this dialog? That is not clear. This is readily corrected. First, rather than using the traditional OK and cancel buttons, let's give buttons meaningful labels that logically answer the question the dialog box is asking. This way the user knows exactly what will happen if they click on each button. Also, the buttons don't have to look alike. We can design buttons that make it harder for the user to hit one by mistake that would be more destructive. Like, instead of saying okay and cancel, we say yes, cancel it. We make that, a little smaller so you can't hit it quite so readily by accident. And you get a bigger green button for the safe option, which says, no, don't do anything that might lose something for you. So that we can be a little more creative than the antique okay and cancel buttons. So the feedback you provide to a user should let them know what to do next. It should be actionable. Here's an error message I often see after I make a backup from my PC to an external hard drive, and then I try to eject the drive. Windows says, I can't stop your attached device. And you think everybody's going to know that that means hard drive? Well, that's what it says. Because the program is still using it. Close any programs that might be using it and then try again later. Well, this is annoying because Windows clearly knows what programs are currently using the drive, but it doesn't tell me what they are. It doesn't give me any way to turn them off. All I can do is close this message box and try to figure it out on my own. I might be able to do that. You might be able to do that, but my wife can't figure out how to do something like that, and she shouldn't have to. It's frustrating and annoying. Now contrast that message with the far more helpful message I get if I try to delete or rename or move a file that's open in an application. Okay, this action can't be completed because the file is open in Microsoft Word. Okay, it's given me some real specific information here, tells me just what's going on and what to do about it. Again, don't think of this kind of feedback as error messages, but as guidance to help the user solve a problem. So here's an example of thoughtful design that makes messages polite. I use Mozilla Thunderbird for email. Thunderbird looks for keywords that suggest you might have an attachment for the email you're writing. Keywords like attached, attaching, enclosed, .pdf. Even better, you can customize that list of keywords for it to look for. And what it does is if it sees one of those, it gives you a little notice when you try to send it. If you didn't have an attachment on it, did you forget to add an attachment? No, send now. Oh, I did. So you see, we're answering the question with the prompts that are in those options. I think that's pretty friendly and polite. And notice how they're labeled in a way that you're going to know exactly what will result from each action. So this message hits all 7 of the desirable characteristics of feedback to the user. It's a 7-way winner. So wouldn't it be nice if all the messages that we saw from computer systems and hardware devices were like that? I think that'd be nice. Let's not waste the user's time. I think that's a pretty good design principle. Here's the homepage for a financial services website that I use. And in my opinion, this is 100% content free. I don't know who that guy is. I don't know why I'm looking at him. What I do want to do is log in, but the login fields are below the fold. That is, I have to scroll down or page down to access them. Or I could click on that tiny little login prompt or log on prompt in the upper right part that I've circled here, making me take extra actions like paging around to get to the input fields. That wastes my time. Now, maybe the company who owns this page did some research and they found that the majority of visitors who land on the page, they want to look at that guy with his cup of coffee and click on the promotional link in that big black space. But I doubt it. I bet most people who see this page just want to log into their account or look something up as efficiently as possible. Interestingly, I don't think it's because they read my book, but I'll take some credit. This website has been changed within the last 6 months or so. And now at the very bottom, you do see the login fields, and that's all I wanted them to do. Other kinds of time wasters that bug me include this current fashionable website design style with huge fonts, meaningless stock images, lots of white space that require the user to scroll to get to anything you're interested in. What a waste. I just don't understand that at all. And it's especially stupid when you figure that a lot of people are using smaller devices with less screen space to work from. Sometimes I waste time trying to find the logout button on a website or a phone app. Cleverly concealed options like that suggest that the site owner doesn't really want you to log out, but that's my choice. it should be easy to find the log out button. So the main lesson here, let's let the user take the fewest possible actions to accomplish a task. I don't think that's unreasonable. Now, one way we can do that to avoid wasting users' time is for the designer to make it easy for users to access the tasks that they perform the most frequently. So a good way to lay out screens is to collect some data on how people use the application. And we can turn to the domain of software reliability engineering and use an operational profile. An operational profile defines what percentage of the time users will perform various tasks at a menu or a screen. And this helps UX designers set defaults and priorities for screen layouts and menu items to save users time. So this is a screenshot from another financial services provider. They've obviously collected data on the frequency of different kinds of transfers and payments. They put the one that's used the most frequently at the top, and they even labeled it. There's actually more options than just these three too. So it's nice to have them sorted in some most likely to use sequence. And that is indeed the one that I always use. So this layout saves me time. I don't have to scroll around looking for the menu option. It's boom, right there at the top. Now, avoiding one or two clicks or scrolls might not seem like much of a time savings, but multiply that times millions of users and many millions of sessions, and it turns into a lot of clicks and a lot of time saved. Too many application designers seem to view their customers' time as being free. It is not. All right, so one morning I went shopping at two supermarkets. The cashier at one was friendly and efficient. Before I knew it, my bags were full and I had the receipt in hand. But the cashier at the other store kept giving me instructions. I had to do things in a certain order. The cashier became impatient with me if I took too long pulling out my loyalty card or making payment. I might have forgotten to mention that the first cashier was a pleasant young woman, and the cashier at the second store was this machine. I think it's hard to think of a product less thoughtfully designed for the user's convenience than your typical supermarket self-checkout station. Now, some are better than others. If you're doing something simple that doesn't require anything being weighed like produce, no products without a barcode, no coupons, no alcohol, then they can be okay. But otherwise, they're often problematic. I remember one time I was at my local supermarket and I was buying exactly 3 things. And in the process of attempting to buy those, the machine decided it needed to call for help 3 times. I've been known to just give up on these things and just leave my basket of food there, walk out and go someplace else to buy it. But usually you can struggle through, but it seems like they could be done so much better. So the lesson here is that products should be designed to tolerate both technical faults and unexpected, imprecise human behavior. Here are some other lessons relating to the idea of designing for the user's convenience. One thing we can do is let the user customize their experience whenever possible. That's a big help. Customization is a good way to reach a sensible balance between ease of learning and ease of use. And it's also a way to make a product usable by a wide range of customers. My car lets me customize many aspects of its behavior through the electronics, and that's convenient. Lets me do what I want to do with it. Another way to enhance the user's convenience is to let the computer do as much of the work as possible. For example, have you ever typed in some long entry on a web page, say like in a problem report, only to be told when you try to submit it that it's too long, but you were never told what the maximum length is? You might not be told how much you need to take out. If you have an input field with a character limit, don't make the user guess at how many characters they can enter. Tell them, and then tell them how many they have left. Then stop taking input when they reach the limit instead of letting them type, and then showing them an error message and say, wait a minute, no, too much. Another good way to consider the user's convenience is to design packaging for physical products that customers can open easily and safely. I just don't understand why we experience so many packaging failures. I have several examples in the book, and I'm sure you've had your own experiences with poorly designed packages. Why is this a problem? Cardboard and plastic are not new technologies. I don't get it. I want to warn you about some kind of other designs that are not definitely designed for the convenience of the user. The word thoughtless can mean either showing a lack of thought or inconsiderate of others. So far, we've seen examples of products that, in my opinion, showed a lack of thought in their design. But some websites are deliberately inconsiderate of the users, and some of them are designed to be downright devious. Here's an example from the website of the bank that issued one of my 2 credit cards. When I go to pay my bill, this payment page doesn't show how much I owe anywhere on it. It only shows in those 3 red boxes in 3 places the minimum payment due of $25. There's nowhere here that it says, here's how much you owe us. I need to click on this little e-bills link in that red oval now to find out how much I actually owe them this month. This website is clearly designed for the benefit of the business, not the consumer. I think the opposite is important, designed for the benefit of the consumer. These people want me to pay the minimum every month so they can charge me millions of dollars of interest. There are all kinds of so-called dark patterns like this, ranging from various subtle deceptions, which is what I would consider this, to downright fraud. You have to be careful to understand just what will happen when you click on some button. Interestingly, the company that owns my other credit card, that issued the other credit card, that bank has a much better website that makes it really clear what you owe and gives you all the right options right up front. I like that one a lot better. Now, the 8th principle here is that we need to accommodate the range of human variation. Human characteristics span a very wide range of differences in multiple dimensions. And so we need to be able to accommodate to the best of our ability these differences in the 8 or so billion people that we have hanging around on the planet now. While it might not be possible to make every product equally usable by everybody, designers should respect the variations and be as inclusive as possible. Here are 2 examples of thoughtless designs that don't account for some of that human variation. 2 of my friends reported the same design problems. One's a man in his late 60s, the other's a woman in her late 70s. They both live in condos in different retirement communities, and they both reported the same problem. The furnace filters in their condos, which need to be replaced periodically, are installed at the top of a 12-foot high ceiling. Now, the condo designers knew that these were for older people, some with disabilities, probably none of whom feel like climbing up on 12-foot high ladders. And so this is just inconsiderate, thoughtless design. Another friend works for a utility company. She creates maps of access roads so people can service power transformers and the like. The roads on these maps are color-coded, so they know which ones they can drive on and which ones they can't. But the people who defined the mapping conventions, not my friend, fortunately, chose colors that some colorblind drivers cannot distinguish. Colorblindness is quite common. So any visual display needs to account for the possibility of users who have color vision variations. Now, here are 2 thoughtfully designed products that accommodate some of that range of human variation. About 10% of the population is left-handed, but a lot of products are much easier for right-handed people to use. These days, many computer mice are symmetrical, and computer operating systems let the user configure the buttons to be logical for either right or left-handed people. And this is an example of how making systems configurable and customizable increases their usability. In these apparently never-ending fun days of COVID-19, most people have been wearing face masks. At least up here in Oregon, they're really good about that. But face masks pose a communication barrier for people who are hearing impaired and read lips. You also lose a lot of the emotional contact associated with communication by covering up a significant fraction of the face. Some companies have designed masks like this one with clear plastic, so you can see the person behind the mask. I think this is clever and considerate design. My final design principle is to place the minimum mental burden on the user. Now, here's the screen I see when I ask to log out from one website that I use periodically. The system displays this message: "Are you sure you want to log out? Any unsaved data will be lost." It warns me about that, but that's the problem. Now, the system knows if I have any unsaved data left during my session. I might not know that. So it should only warn me about this if I really do have unsaved data. If so, tell me what the data is and tell me how to get back to the right screen to fix the problem. This is an example of non-actionable user feedback. I don't know what I'm supposed to do with that information, except get nervous that maybe I did something wrong and I leave prematurely. The simple improvement of warning the user only when there really is unsaved data and then helping them to save it would completely solve the problem with this website. Another important lesson is to make the functionality that's shared by multiple members of a product family consistent. That enhances both ease of learning and ease of use, and it facilitates software reuse. As an example, have you ever noticed how many different ways there are to delete objects on an iPhone? The prompts, the icons, the actions all vary depending on what kind of item that you're deleting. Sometimes you need to confirm a deletion, sometimes you don't. You might have to confirm deletion of a single object, but not confirm deleting a whole group of the same items. Now, which of those is more destructive, riskier? It seems like the teams that built each app decided to implement the delete function however they wanted to, without any overarching consistent architecture. This confuses users, it increases their learning curve, and increases their error rate. Yet another inconsistency shows up once again in Microsoft Office. We do expect a lot of common behavior across Word, PowerPoint, and Excel, and there is, but there are enough inconsistencies to waste my time or cause problems when I try to do something that works in one or two applications, but not in all of them. And here's a couple of examples of where shortcut keys do different things in Excel than they do in Word and PowerPoint. All right, I want to wrap up here by summarizing several good practices that can lead to more thoughtful designs of any product. If you agree with my premise that usage-centered design is superior to product or feature-centered design, let's begin by understanding our stakeholders. Customers constitute a subset of stakeholders, and user classes, of which there are usually several, constitute a subset of customers. And so remember, just about every product doesn't have a type of user. It has multiple user classes whose needs the design must address. Now, during requirements development and design, you need to engage appropriate customer representatives of these various user classes so that you can understand their needs and can validate solution ideas as we get into that exploration. I call these user class representatives product champions. The product champion approach is a strategy that we adopted when I was working in a software development group at a corporation in 1985. This is not a new idea, but it is really, really valuable. So the product champions then work with a BA or a requirements analyst or product manager or product owner to bridge the gap between customers who have needs and developers who craft solutions. Some other good practices here. Personas can serve as stand-ins for human beings when you don't have a real person to represent a particular user community, although we prefer to have the real people. Prototyping is an excellent way to iteratively understand requirements and evolve designs. A prototype is a partial, preliminary, or possible solution to your problem. It's a lot easier for users to envision what a product might be like and how they'd use it from a tangible prototype instead of a bunch of textual requirements and diagrams. So here's a cycle of steps that you might go through when you're using prototypes to design a product. You develop some initial set of requirements, which leads you to conceive at least one possible solution. You can create a prototype, and these can range from very simple sketches on a whiteboard to running software and everything in between, and get some customers to evaluate those prototypes and provide feedback so we can both understand refine our understanding of the problem, refine our requirements, and then go back and conceive better solutions. And this is where the iteration starts kicking in. Even informal usability testing can reveal places where users are confused or make mistakes or take too many steps to get something done. The simplest approach is to just watch people try to use your product or a prototype of it. But if you're really serious about usability, you can do formal usability testing. Many years ago, I participated in a usability study at an IBM lab. I was working for Kodak in Rochester, New York. And I don't know how I got in this list, but IBM flew me down to Texas, and I sat in a big room in a usability lab for a few hours, and I ran through some scripts that they had prepared of things they wanted me to do with the next version of their office automation package that they were working on. I was familiar with the current version. And I had these microphones on, I had cameras on my face, on my hands, on my screen, so they could see just what I was doing. And I just told them what I was thinking and trying to do as I went along. It was really kind of fun and interesting and hopefully useful for them. Finally, every organization should learn from its previous experiences so it can do the next job even better. Project retrospectives and collecting and analyzing customer feedback are good ways to continuously improve your designs. So if you take away nothing else from this presentation, please remember the first 3 lessons I showed you. Let's focus design on usage, not on product features. Lesson 2 tells us that design demands iteration, and lesson 3 recommends that we involve real users. Those 3 lessons alone can help you avoid creating thoughtlessly designed products. So thank you for joining us today. I hope you got some information that you can use from this presentation. If you want to learn more about the book, go to the thoughtless-design.com website. I've also got some supplemental information with a lot of additional examples and analysis there. My business website is processimpact.com. My personal site is karlwiegers.com, and that's where you can hear the songs that I've recorded. They're all just for fun. I'm certainly no professional, but I've got about 50 songs there that I've recorded. I think 18 that I've written, and the rest are covers of other people's songs. It's just a fun, creative hobby. Some years ago, my wife said, "You need a new hobby." Well, I've played guitar forever, but I started recording songs then, and she hasn't suggested I need any new hobbies lately. I guess she learned her lesson. So I guess I can leave that up. And let me go back to my camera and see if anybody has any questions or examples of other products they can share with us of their own experiences with thoughtless design.
Dr. Depradine, and then Dr. Mansing.
Yes, afternoon. Thank you for a very interesting presentation. I too suffered with the iPhone timer not too long ago, scratching my head. And so I'm glad to hear it wasn't just me.
I feel better too.
I have a couple of examples here. Sometimes products tested overseas may work well, but don't work well here. One of the products, like you mentioned, the mask with the transparent cover. We found over here that when we tried to use them, they fog up. And so we had to abandon using them for our students with hearing impairments because they kept fogging up in our weather. So it didn't work well over here. I don't know if it's the brand or the weather, I'm not sure.
Yeah, there are a lot of variables, and that's interesting because that kind of gets to the point of making sure that the products work in a variety of typical operating environments.
Exactly. So we couldn't figure out, well, we're not the testers, so we couldn't figure out one really. But we did try a few. It didn't quite work out, but we're still at it. We may find one that actually works. But we had a recent instance here in this is in Barbados, where a bank, it's not a local bank, it's a bank from overseas that has branches here, decided to upgrade the ATM machines in an effort to reduce the traffic in the bank because of COVID. But in their brilliance, what they did is they caused a lot of confusion. But the thing that was most disheartening, and I heard this from our persons with disabilities, they decided to put a white text on a light gray background. No. And it just made it impossible for including myself, for all of us, besides the fact that the features were all moved, everything was changed. And as some of the examples, we couldn't figure out as an average user. So they did succeed. People stopped going to the ATM. So
they go to some other bank.
Exactly. People just gave up with it. So, yeah, so we have that. And so our blind community now finds themselves unable for that particular bank to do any sort of transaction and have had to resort to getting help. And now all their private information is exposed because, you know, you see what I mean? So yeah, we are trying to get the bank to change, but the design came from headquarters, so we can't get it. Yeah.
But isn't that one of those cases where you just wonder What were you thinking? Have you never used something like this before? Did you not ask people to try this and see how it worked before you inflicted it on everyone? You know, isn't that your reaction when you see something like that?
Exactly, 100%. So a lot of your examples hit home, and I really wish that some of our designers here in Barbados could sit down and hear you and learn, because they do some things that, especially with websites here, that are beyond confusing, to say the least. So
I'm really
thanks again
glad
for your presentation.
Sorry.
Yeah, go
Oh,
ahead.
great, thanks. I really appreciate you sharing those examples, and I'm very glad you mentioned the text, because that is something that I see as a very disturbing trend of people seem to use lighter and lighter gray for text on websites. And then, as you said, you know, you get a light gray or maybe medium gray text against a light gray background. There's just not enough contrast. And I frankly don't see a problem with using black. What's wrong with black when you're trying to see something, particularly under poor lighting conditions? So I just don't have much patience. You know, my eyes are probably older than most of your eyes, but I like high contrast in text, not some medium gray that I have to try to pick out and work hard. I don't want to work hard to read text on a screen. That shouldn't be a problem.
Agree 100%. 100%. Thanks a lot.
Thank you.
Gunjan, you can go ahead.
Thank you so much for that really wonderful presentation. Enjoyed it thoroughly. Your examples were fabulous. And you know, this thing about most of the designers and not been users was just so true. And even what you have, lesson number 1, I think I'm guilty of that. I think we all may be guilty of that, that we
Sure.
often even buy things for features and not for usage. I know when I'm buying a computer, I want this, this, and this, and this, and I may not ever end up using it. And it's always you know, that in our mind as people who are users, that we want everything and we may never end up even using it. So I think these are very, very important design features and reminders to all of us, and especially to designers. And just sharing with you one, you know, one Thoughtless design, and I think several of us in the call have probably used it. We use Blackboard Collaborate as our, for our classes, virtual classes, and the whiteboard in the Blackboard Collaborate, which I think is quite of an oxymoron. If you try to erase one piece of the board, it erases the entire thing.
Bad.
I think they may have changed it subsequently. You had to select a piece. You know, you had to go select to delete. If you press delete, you would think like a whiteboard eraser, you can go erase it, and it would just erase everything. I think we had to discuss and find workarounds to see how we could make it happen. But
so that's very interesting, because what they're doing with an electronic whiteboard or blackboard, they're building on the metaphor of what we're used to with physical whiteboards and blackboards, but they've broken the metaphor by giving it behaviors that are not intuitive from your mental translation from, okay, I've got a physical whiteboard here, I want to erase this piece. And they've broken that metaphor by doing something different with it.
Yep. Totally. And it became actually a big problem for us to figure out how to make that happen.
Yeah.
And we had to use alternatives. So in a very, very important presentation for all of us in this field. Thank you so much.
Great. No, my pleasure. You know, talking about the things we use these days, you know, when everybody's remote, Zoom itself has, I think, a lot of great features and some really thoughtless design. For example, depending on what view of Zoom you're in, there's a menu bar. And if you float your mouse over that menu bar and then don't do anything for a few seconds, it goes away. Now, you don't get more screen space to, see the participants in the session or anything. It just goes away and leaves you a black bar for no reason whatsoever. There's no value provided. And then I have to figure out, wait a minute, where did that go? Who decided how quickly I was reading all of those things? You have to, try to mouse around and get something to come back again. And that's just stupid.
Nicholas, you can go ahead. I just wanted to just comment first that particular problem, I've actually searched to find a solution for why I can't keep my menu bar there. Nicholas, you can go ahead.
It's discouraging.
Hi, good day. Thank you so much for that really informative session. I was just wondering, I know some of those lessons that you show, I had the unfortunate experience of learning them the really hard way. So I'm so grateful that you give me other ones to look out for. And I was just thinking about, I mentor several student groups like in the capstone, and they may not have all the time to schedule these really important, these critical rituals, formal rituals, like probably usability, testing, and even like when they communicate with the end users, they have very limited opportunities. So I'm wondering what you would advise to them in a really minimalistic approach to probably what are the most important things they should probably look out for.
Well, that's a very good question. Thanks. It's basically the same answer as almost anything we do in software, which is based on risk. You know, where would be the greatest opportunities for something to go wrong or cause problems? What kinds of problems could be the most impactful and dangerous? And so I would encourage people in a case like that, when you have limited bandwidth to interact with others and explore these issues, to try to think about, where's the problem? And one of the issues might be, what are the most common usage scenarios that we want to make sure most people are going to encounter and not have problems with them? So you could focus your attention where the common usage is. And that way you spend a little less time, just like you would probably spend less time testing low probability scenarios or use cases that aren't likely to be encountered by most people. So I would have people, again, reach an understanding, what are people going to do the most often with this product? And let's make sure that those are designed the best. And very often I would guess that the lessons you get from how to design those parts of the system well could then be translated and applied to other parts where maybe you don't have the need or the opportunity to do more detailed exploration.
Okay, awesome. Thank you very much.
All right, thank you very much for all the questions. Before we're going to continue with questions and answers if people have further questions, but we're going to pause a little bit and I'm going to invite Jason to take the floor because he's going to, Karl has offered to give somebody a free copy of his book today. And so Jason is going to take the floor now. We're going to give our gate prize. So he's going to do the selection. Jason, the floor is yours.
Okay, hey guys, so I'm going to just spin a short wheel so you guys can win, hopefully win a prize. All right, let's go. Oh, don't mind my background. Okay. Let's see. And the winner is Rashid Sr. So come to the floor, Rashid, if you're in the call.
Well, if
Okay,
someone
he's
can
in the
send me
call.
Rashid's contact information, I'll be happy to send you information where you can download a free copy of the ebook.
Thank you so much. I really appreciate the opportunity. Let me send you my email address.
Okay.
All right, so back to you, Alan.
Thank you for that, Jason. Okay, so the floor is still open. Dr. Wiegers, thank you so much for being here and for sharing definitely what is, I mean, we are familiar with some of these things and we get, we have conversations about these kind of things, but you have really brought together quite a number of them. And then the book is packed with a whole lot more of these ideas for us to consider and think about. And I think it will make, I mean, I expect that it's even going to make a difference to some of the projects and the way that some of the projects that we'll see at the end of the semester, the way that they're designed. All right,
Great.
so I'm just reopening the floor in case anybody has any further questions or if Karl, you'd like to say anything else.
I'll see if there's some questions or other stories to share.
I would like to ask a question. So we have this, as I told you.
Doesn't look like it. We probably reached the end of a long day for everybody, so they're probably ready to stop Zooming for a change. And I'm happy to have the chance to talk with you.
Karl, hold a sec. I have one question for you before you go. Oh my,
okay.
Can you hear me? Hearing me clearly? Okay, so my one question for you, as I told you, we have this requirements engineering course that we're doing and students are getting excited. It's a small course. We have 13 students actually, and they're getting excited about this, the career path called business analyst. I'm wondering if you could share, there are quite a few of those students in this session now. I was wondering if you could share in, some nuggets or ideas about some of the things that persons who are interested in that career path would need to develop, work on, that type of thing. Thank you.
Okay. Yeah, I think some things worth keeping in mind as if you're going to be going down the business analyst path is, first of all, it's a very important bridging function. I think of the business analyst as essentially facilitating communication from among all of the other participants on a project. You have to be able to work with user representatives and other kinds of customers and stakeholders who aren't users, but are stakeholders and participants. You need to take their input, and you're not a scribe. You're not just writing down whatever people tell you they need. In fact, the very worst questions that you can ask when you're exploring requirements are, what do you want? And what are your requirements? Those are not good questions to ask. And that's, again, why I keep stressing the value of taking a usage-centric approach. A better way to structure those conversations is to ask, what do you need to do? If you're going to have a session with this system we're describing, tell me what you'd be trying to accomplish during those sessions. So keeping the focus on usage, just as I've stressed in this presentation, is I think valuable. And then you need to take that information, you need to organize it and classify it. You can't just put it all in a great big list of sticky notes or things you're going to call user stories. I am not a fan of user stories. It's too easy to just get a pile of information from that. And you need to figure out what kind of information did you get from each of these conversations. Is it a piece of functionality? Is it a business rule we're going to have to respect in the software? Is it a piece of data we're going to have to do something with? And you have to organize that in some structured way that you can then communicate to all of the other participants in the project so they can use it to do their part of the work. So as a BA, you perform a very important bridging function. Now, BAs can come from different backgrounds. Some people come from the user side, some come from a more technical side, but whichever way you come from, if you've got this job of being able to communicate effectively with people who have different roles on the project, you have to know how to communicate with them. So there's going to be gaps in your knowledge. And I think what you need to do is a self-assessment so that you can judge, where are those gaps in my knowledge? How can I close those gaps so I can work more effectively with these various communities? And if you're coming from a business side and moving into BA function, you might need to learn more about how do I communicate to technical people, what they need to know at their level of detail. And in ways that's useful for them. If you're coming from the technical side, you're going to have to learn more about the vocabulary and business of the user side. So be sure to recognize that there's stuff you're going to have to learn to be able to bridge that effectively. And there's a lot of different skills you need. It's a communication-centric function, and you're probably good at some of these things already, but maybe other areas you're going to have to enhance your, say, listening skills or facilitation skills or writing skills. So I think it's good to kind of read about what sorts of skills help make BAs be effective, and then just be honest and with your own self-assessment about where you need to close some gaps so that you can be more effective. I mean, we could talk about BA stuff for days, but I think those are some of the most important points.
Thank you so much. Colin?
I thought you might find this story a little funny. While going overseas on business for the university, I was put into a hotel that everything was automated. So when I went in the bathroom, I couldn't figure out anything. So for example, the toilet had buttons, but not one said flush. Turns out that what happens is that when you approach the toilet, the seat opens automatically, and when you get off, it flushes automatically.
Wow.
But you can understand, you come from a long trip, you want to use the bathroom, and you can't figure out, I couldn't figure out how to use the tap, I couldn't figure out how to use the shower. I had to ask for instructions because too much automation and no instructions whatsoever.
Yeah, and this is something that we pretty much all know how to do and do pretty much every day. And you'd think that that would not be such a challenge. And I'm sure people build things in good faith. I don't mean to suggest people build stuff deliberately badly, but something that's that ordinary and common to every human being, you think should not be that hard to try to figure out, as you say, especially when you're tired and you just want to go and use the facilities and get on with your day. It reminds me of a very old joke about some guy who goes up to a new vending machine for coffees and drinks and stuff. So he puts in his money and he selects the coffee he wants and the kind of milk he wants and whether he wants sweeteners and all this stuff. And the thing starts whirring. No cup appears, but then all these nozzles start spewing out fluids and never gets his coffee because there was never a cup. And he says, wow, that's really automated. It even drinks it for you. That was a little too much automation, I think. So I'm sorry you had to go through that, but you just wouldn't expect that, would you? You'd think something would be a little more obvious.
Okay, so once again, Karl, thank you so much for making yourself available for us and for our
My
students.
pleasure.
I'm seeing comments in the chat. I think students really do appreciate the time that was spent. Some of these are students from the said requirements engineering course. Some are from object-oriented design and other courses and from various campuses. So thanks again for your time and the quality and the nature of your presentation. We really appreciate it.
Well, you're very welcome. Thanks for the chance to visit with you and good luck with your next round of designs, everybody. Take care. Bye-bye.